In today's tutorial, we're going to go over a concept in RayTK called iteration. And as usual, going to start by going to the GitHub repository. There's a link in the description. And then going to the releases page. And the latest version that we're going to be doing this tutorial in is 0.12. So scroll down until you find the tux file and download that and drop that into your project. Now that we've got the toolkit loaded up in the project, I'm going to start by creating a Raymarch renderer. So I'm going to do RR3, Raymarch Render 3D as a shortcut. You can also just type out the full name if you want. Going to add a null at the end here for the rendered output, and I'm going to split this pane left and right, set the display flag on here, and then set the this panel to top viewer, resize that, and then turn off display background tops in this one. So we've got the rendering on the side, and you can see the network more easily over here. I'm going to, for now, just pick a resolution that kind of fits that shape a little bit better. Just gonna go with 500 by 1000 and scale that down. Once we're done setting things up, we can change that and for doing any actual rendering. So we're going to start by, as usual, by creating an SDF, and I think the one that we're going to use initially is going to be the link SDF. So connect that up to the first input of the renderer here, and you can see it gives you this kind of chain link shape. You can control the length of it or the kind of radius of the curves at the ends of it, or the thickness, and move it around and so on. But I'm going to leave this just at the default settings for now. Iteration is all about varying copies of a shape. So the kind of simplest example of that would be something like reflect. And if we just going to move this off to the side a little bit there, and then add this reflect in between. Other side, move it off to the right. So without it, that's the original one. Reflect mirrors space along an axis like that. So right now, what we have on each side of this is just a pure mirrored copy of the other side. So if you were to add, say, rotate in here, it is always just going to give you, and then change like the Z here. So it's kind of rotating around the center point, which is in between the two at the moment. Another way to kind of visualize this, instead of using translate on this, is just reset that so it's kind of just in the center, and then the reflect operator has an offset parameter that you can kind of you can offset shifts where the reflection plane is, and then the shift plane setting moves like the whole resulting image. So if you set both of those to 1, then it kind of pushes the copy out to the side a little bit. So now when we're rotating around the origin axis, it's that point in the middle of the link now. So you can see that you're always, whatever you do on one side of this, it's always going to be the same as kind of the other side, just flipped. And if we wanted to, just resetting that there, I'm gonna stick in a translate here. And I'm gonna put that after the rotate. All right, so if you're changing the X, then because that's the axis that you're mirroring over, then it'll kind of move in the opposite direction on the other side. But if you change the Y or the Z, it's going to do the same thing on both sides. And you don't really have any control over it beyond that. So iteration is a way to vary things on when you have in cases where you've got an operator that's kind of making multiple slices of space that are repeating space, and it allows things that are kind of upstream of that in the network to know which side they're being used on. And it's a little bit of an abstract concept, but I think the easiest way to show that is so that this reflect operator here has this iteration type setting. And right now it's set to none, but if you change it to index 0 and 1, then everything upstream of that has access to a piece of information about which side it's being used on at that particular moment in the scene. And there are a couple of operators that you can use to access that information and then use it to change settings. So simplest case of this is what's called the iteration switch. And what this does is it allows you to swap out different shapes or other parts of a network depending on which side it's on. So in this case, if we stick in a sphere, or we stick in a sphere box and connect those two to that input there, and then just for illustration purposes, I'm going to switch off iteration for now and then plug this in here. So right now it is, you still get the same shape because nothing is telling, this iteration switch doesn't have anywhere to get to know, anywhere to get the information about which version to use. So when something downstream of that, like this reflect, turns that on, then it's now able to pick between the different inputs depending on which side it's being checked on. And this works for any part of the network that you want to swap in, as long as like the two things that are connected to it are of the same type. So basically anything where you could use like a switch top or a switch chop or something, it's kind of the same behavior as that, but it controls it based on which side it's on. So reflect is one of the ways that you can use that. And I'm gonna take this, add a translate to shift it up so that we're gonna have a couple different versions of things that we're going to compare. So I'm just adding a translate to kind of move it up, there, and then add in a simple union, which in between that translate and the renderer, and so then when we add other stuff, we can kind of stick it down below. So I'm going to kind of copy and paste this link, just the link SDF. You could also create it from the palette if you want. And then add another translate that'll move things down a bit, and then connect this up to the second input of the, well, or any of the other inputs of the simple union. It doesn't, as long, if you can skip inputs in simple union and other ones that kind of take like, you know, between 1 and 4 inputs. It doesn't particularly care which ones are connected, it just does them in order. So we move this down a little bit there. Okay. So I'm actually gonna copy this whole thing with the switch and everything. And go to this other link, and as you can see there, validation error saying there's a required input is missing. Get up there, then it gets what it needs, it's happy. So this is back to the case where, you know, you're using this iteration switch, but nothing is telling it which one to use, so it's just going with the first input in every situation. So we're now going to try a Modulo 1D, and this repeats space along an axis infinitely. And just to get a better view of this, I'm going to create a camera, hook it up to the second input here, and zoom out. All right, move that out, and then you can kind of get it a little bit off, up above, so you get a little bit more of an angle on it. Okay. Now, Modulo 1D, as we said before, is kind of repeating space along that axis. And right now, what it's doing is, you know, when the renderer is asking it, you know, what's over here, it looks at this point instead and gives it the answer for that point. So, and it does the same thing over here. It says, you know, it uses the same response it would give if it was being asked about that point in the middle. And so it's kind of it results in like that, everything within that slice of space kind of being repeated over and over and over. But similar to the reflect, it's kind of always the same in each one of those. The Modulo 1D has an iteration type setting similar to the reflect, and it's got a couple of options, but the one I'm going to go with now is alternating cell coordinates. So this goes back and forth between 0 and 1. So switch that on, and you can now see that for each slice of space, it's alternating what iteration value it uses, and then this switch is using that to pick from the different shapes. And it looks like the box is like a little bit too large there for the iteration, so I'm just going to scale that down so it doesn't get clipped off on the sides. Alright, so you now have the ability to swap in different shapes or different parts of the network in these operators that kind of repeat space. So we're going to also try a cone, and just to show that you can do it for more than just 2 inputs. But right now, that iteration value being provided by this Modulo 1D is just always going back and forth between 0 and 1, so it doesn't really matter. But if you switch it to cell coordinates, then it'll give you kind of 0 for the middle one, and then 1, and then 2, and 3, and so on, and then negative numbers in the other direction. And the reason that it is kind of repeating this first shape off in that direction is because you've got an extend mode setting on the switch, and this is kind of like what the channel extend modes in chops or in the transform top when you're scaling things down, whether you want it to, either just clamp at whatever the value is at the end, or loop, repeating, and scale this out a little bit, and just kind of loop over those values, or you can we'll add a fourth input, like I'll do box frame, and just make sure that's fairly small. Hook it up here, and so now it's doing link, cube, cone, box frame, and then repeating that over and over. You take a look, move the camera off to the side there, you can see it's kind of repeating that pattern. And just to make things a little bit easier to see, I'm going to switch the direction of these so that it is vertical instead of horizontal. So instead of moving this down, we're gonna have it move off to the side, which you can't quite tell yet because of the way it's repeating, but do the same thing on this and change that back down to 0. Change the modulo 1D to use the y-axis instead of x, and increase the size a little bit there, so it's, well, we'll shrink down the shape so it fits a little better. And then for the reflect, we're going to switch to using the y-axis in the positive direction. So now we've got a little bit better view of those, and I'm going to scale down the length of this link so it fits within the way it's been tiling those, and bump up the size of our cone a little bit, and shift it down. All right, now that we can kind of see more of those a little more easily, I'm gonna show the zigzag setting, which will, let me zoom out even further. You can see that it is going with, the first input, second input, third input, fourth input, then back to third, then second, then first, and then so on. This is kind of like the mirror extend mode on chops and end tops. So what we have here has been showing the iteration switch. So just to review, in this first case, we're using a reflect that is reflecting across now the y-axis, and that's down here. So above that, upstream of that, and we can get rid of those because we're not using them. So we've got the reflect operator here, and upstream of that you've got this iteration switch, which has got two different SDFs to pick from, and the reflect here is using iteration type, which gives this enough information to pick between the two. And then in the second case, we've got 4 different variations going into a switch, and instead of using a reflect to give it those values, we're using a modulo 1D, which is repeating space along the y-axis. And if you switch back to loop, then it will kind of repeat in that order rather than going back and forth. And we're then, just for demonstration purposes, moving those two and then merging them with a simple union just so that we can see both. So now that we've demonstrated how iteration switch works, there are a couple other operators that can make use of that iteration information. And I'm going to, just to make things a little bit easier to see, I'm gonna add a null in here and then just make a copy of that whole renderer. And for now, we will switch over to that new one. So this makes, we can go back to the other one later to review. But for now, we'll just get a clear space and just disconnect that. Right now, it's going to show an error about required input missing. It's because you don't have anything connected up to the first input, but we will fix that in a minute. For now, we're going to create another SDF. This time, let's use a box frame and hook that up here. And change the scale so that it's a little bit shorter and longer on the X, and then reduce the Z down to maybe 0.5. So 2 in the X and then 0.5 in Y and Z. And I create another modulo 1D and insert that between the SDF and the renderer here, change the axis to Y, and then change the size so it spaces them out a little bit more. Change it up to maybe 1.5. And we've now got kind of a similar situation to what we had in the first part, where it is repeating this shape, but whatever you do to this is always going to be the same for each one of those slices of space. So this time, to add some variation in there, we're going to use the range transform. Now, important thing to note about this is that it is currently in beta, which means that it's not shown by default. So you got to switch on this little B symbol, beta symbol, and then when you type it in, it'll show up, and it'll show this little icon next to it just to indicate that it's in beta. And what that means is that it's kind of early in development and might change a little bit in the next version, but it generally should work. And it'll show a different color in there and a little icon just to indicate that. Now, if we connect this in here, you can see that it has some translate settings and rotate settings. I'm going to turn off translate and rotate, and then look at rotate. Now, if we change the Y rotate, you can see that it is kind of spinning all of the shapes, but then there is a second rotate setting, which right now isn't going to do anything. And that's because it bases that on iteration values. So, and currently nothing is providing that. So to provide that, we're going to set the iteration type here to cell coordinates. So that's going to be kind of 0, 1, 2, 3, and so on, and then negative numbers on the other direction. And range transform, similar to iteration switch, has this concept of an extend mode. So you can give it an index range, and this is kind of the range of cells that it will spread those values over. So for now, just to demonstrate this, I'm going to switch to clamp, which is just going to cap it at either 0 or 1. And if we change the rotation now, in this first rotation, you can see that it is only applying to some of them. And if you change the rotation in the other one, then it's applying to the others. And this is because this is the 0, and then I guess this is the 1, and then the negatives seem to be going in the other direction, which is a little confusing, but I'll try to fix that in the next version. So right now this is, kind of useful, I guess, but not that useful. But if you change the range here, so instead of just going 0 and 1, I'm going to go like -2 to +2. Now you can see that it is applying a range of rotations to each instant, to each kind of slice of space, and going from 20 degrees on one side to -80 on the other. And because we're using this clamp setting, it is kind of capping out at the -2 and +2 indexes. You can also switch it to loop, which will repeat that pattern. So you can now see that it's got 1, 2, 3, 4, and then 1, 2, 3, or -2, -1, +1, +2, so on. And it's kind of repeating that over that range. And there's also linear, which will extend it out beyond those. So it'll say, you've got this point, the -2, which has this setting of 20. Then you've got this other point, the +2, that has this -40. And then after outside that range, it'll just kind of continue going, and the value will continue going in the same direction at the same slope as it does within that range. So what that looks like here is a continuously increasing or decreasing rotation, depending on which side you're on. And for rotation, that works particularly well because you can kind of get this just infinitely twisting pattern. And if you use the shift parameter on the Modulo 2D, that'll kind of just move this along and just keep going to larger and larger values. You can just keep going infinitely in either direction. And it will just apply, more and more and more, or less and less and less, depending on which direction the slope is. So this is using the range transform to apply different amounts of rotation to each different slice of space that's coming out of this Modulo 1D. And you may be thinking about the twist operator and how it's kind of similar to this. We're now going to show the ways that is a little bit different. So I'm going to create a twist, connect it up to that same box frame one. So if you swap that in here, because nothing upstream now is making use of the iteration, it doesn't really matter that this is setting it. They're just ignoring it further upstream. So twist, if we apply it to the y-axis, you can see that it is kind of doing a similar thing in that it's applying different amounts of rotation, but because this is before the modulo, it is happening kind of within the context of each unit before it tiles the space. So if you instead connect it after that, so it's now doing something kind of similar to what it was doing with range transform. And if you increase it up high enough, you can see that it is applying different amounts of rotation, not just to the different slices, but to every point within those slices. And so it's now, warping these boxes in addition to, doing it to each the parts as it goes along this axis. This is another thing where sometimes that's what you want, sometimes that is not what you want. So the way to achieve that, without dealing with iteration and just kind of applying it over space as a whole, is to use twist. There's also, you can also do the same thing, and we covered this in one of the earlier tutorials about value fields. But if we swap in a rotate here, change this to axis, and then create a axis distance field and a rescale field, and connect it up to the second one. So this will, and then bump this value up higher. So what this is doing here is the rotate is using this second input to figure out how much, to rotate around that axis at any given point in space. This is basically exactly the same as what twist does when you're using this axis distance as the input to there. Twist is just kind of a shorthand way of doing that same thing. I'm gonna go back to using iteration, and we're going to show a similar thing with similar thing to range transform, but doing it in a way with a value field. Now, I'm going to create another rotate here. Set that to axis, make sure it's the y-axis, and connect it in here instead of the range transform. And instead of using the kind of axis distance, or like just the y coordinate to figure out how much rotation to apply, we're going to use an iteration field. Now, what this does is kind of similar to range transform and iteration switch, in that it will look for an iteration value coming from something downstream of it, and it will just provide this as a value field that operators like rotate can make use of. And if we connect that up right now, it's and switch the format here. So right now it's doing full vector, which is giving iteration values can have, so far we've dealt with ones that just have one value of, position, like slice along this one axis, or for reflection it's, which side. There are other cases like Modulo 2D where it's got, two different coordinate iteration values. So what we want right now is just the first one. And this can be a little bit counterintuitive since it's, the x and we're dealing with the y-axis, but just think of the x as being like the first and main iteration value that's coming from whatever's downstream. Now, right now this isn't doing a whole lot because the values that this produces are going to be pretty small. It's going to be, 0, 1, 2, 3. So rotating by that many degrees doesn't really give you much. But if you add a rescale field in between, you can increase that by changing this high output. There you go. And what this is now doing is basically equivalent to what range transform is doing, where it is applying different amounts of rotation depending on which cell it's in. But the way that it's doing that, instead of just using range transform's built-in features for that, it's using an iteration field using the X channel out of that, and then using Rescale Field to kind of increase that to a larger range of values. That's then being fed into the second input on rotate, which is the one that it uses to figure out how much rotation to use. And you can actually reproduce the same behavior as the in the range transform using a limit field in between here. So what this is going to do, by default it doesn't do anything, but the limit type gives you options that are similar to the ones in range transform, where if you go to clamp, then you can see that it is limiting those values to just, the 0 to 1 range, or you could, increase it to -2 to +2, so it's the same settings as that. Or you can switch it to loop, which will kind of repeat that pattern, and you can even use zigzag, which will kind of oscillate back and forth between it. So you can see here it's kind of going in one direction and then it reverses in the other direction and keeps going. So this lets you do kind of the same types of limiting that range transform does, but you get a little bit more control over it if you need that. And if you turn it off, then it's just the same as using like the linear mode. So just gonna clean up some of those things we're not using anymore. And because you're dealing with a value field input that's being used to figure out the rotation, right now we're using iteration as the way to get that setting, but there's all kinds of other value fields that you can use to come up with other types of settings, and you can combine those. And if we were to add an LFO field, so this is a time-based value, and change it to sine wave, and if we were just gonna increase it there, it's going back and forth over right now a 4-second interval on the timeline. And if you change that to like absolute time, then it will it doesn't care about when the timeline ends and begins. It's just kind of the time in a global sense. And if you increase the amplitude, it will use larger range of values, similar to what we're doing with the rescale. So I'm just going to go back to 1 for that for now. Now we've got these two different fields, and you can use a combine fields operator to merge those. And once you hook up two different options and swap that in here, so now you're getting a mix of the iteration cell-based settings and also a time-based value. You could do this by using like a chop or an expression or something to change the setting in there on the field that way, but using LFO field is can be a bit faster. It also gives you a little bit more control over how you're working with it in a scene, but either approach is okay. So just to recap, we've covered a few different ways that you can use iteration values to vary things when you're dealing with operators that kind of repeat or tile space. And in this one, we're using these switches, in the first case with a reflect just picking between two things for the two different sides of that reflection plane. In this one, we're using a modulo 1D that's repeating along the y-axis, and that's switching between these 4 different input shapes. Then in the second example here, we are using you've got a box frame, it's going into a rotate, and the rotate is using this field to figure out how much rotation to apply. That's being based on the iteration field using the X channel, which is going into limit, which we aren't actually even using, so I can just delete that. That's being combined here with an LFO field, which is to a time-based value. And if you want to just switch that off, you can just switch off the setting there. Then that's going into a rescale field because the values that are coming out of this are, small numbers, and this is expecting degrees of rotation. So 1 degree of rotation isn't going to show up much. So we're using this to increase the size of that value. It's going into this modulo 1D, which, as we said, is repeating space, and this is the source of the iteration values. And then that's just going straight into the renderer. So far, we've been dealing with iteration values that are just a single value. So for reflect, that's which side it's on. And for modulo 1D, it's which slice it is along this axis. But there are other operators that can provide more than one iteration value. Going to just clear out some of this old stuff that we don't really need anymore. I'm going to keep this switch with 4 items, and the renderer and the camera, and just get rid of the rest. So it's now going to complain about not having anything connected. You swap that in here. We've got our single item, and since nothing is providing an iteration value, it's just defaulting to the first one. So this is all basically the same as what we were doing with modulo 1D. This time we are going to create a modulo 2D and insert that in between here. And so now you can see that it is repeating space along 2 different axes in a grid instead of just doing it along 1 axis. And we've covered this in some of the other tutorials, talking about the mirroring options and so on, but for now we're just going to focus on the iteration aspect of it. So by default, it's not providing any iteration values, so still this switch is just defaulting to the first item. Similar to modulo 1D, it's got an iteration type setting, which defaults to none. And it has a couple of options, and the options here are different from the ones for the 1D version. And the first option here is called Quadrant Index, and if we switch that on, and see what it's doing is it's kind of grouping these cells in the grid into clusters of 4 and numbering them 0, 1, 2, and then 3. And then for the next group of 4, it goes 0, 1, 2, 3, and so on. And this still gives you a single iteration value, similar to what modulo 1D is doing. And so this is basically operating in the same way as that one, the modulo 1D was. The other 2 options in here provide more than one value. So the first one here is cell coordinates, which by default, since so what cell coordinates does is it provides one value which is along 1 axis, so 0, 1, 2, 3, and so on. And then a second value, which is along the other axis, numbered similarly. And right now, the iteration switch is just looking at that first one. So it's just using, right now the x-axis. And there's a setting in here for the iteration part. So this is which part of the iteration value that it should use to switch between things. And it's got 4 different options of the 4 different possible parts of the iteration value, the x, y, z, and mysterious 4th dimension w. So if we switch this to y here, so it's now using the second part of that iteration value to pick between the shapes, which right now is the y-axis. It's worth noting that although currently in these settings, this is repeating along x and y, and it's filling out the x and the y parts of the iteration, it's not necessarily going to be like that always. So if you were to be repeating along y and z, which kind of hard to see there, so if you're repeating this along y and z, then the first part of this iteration is going to actually be the y-axis, and the second part is going to be z. It can get a little bit confusing, but it's better to just think of iteration as a 4-part value rather than like specific axes. And different operators could fill those in different ways. So it's important to kind of pay attention to what's providing that value. I'm going to go back to x and y on that, and bring the camera back and to the middle. So even though this is providing 2 different values in that iteration type, this is still only actually using one of them at a time. It's just that we're picking which of them we want to use. If we are working with other operators like iteration field, you can actually make use of both parts at the same time. Now, similar to what we did before, I'm going to create a rotate, and we're going to put that between just that first link and the modulo here, so it's no longer going to be using the switch to repeat those, and we can actually just get rid of those since we don't need them anymore. Move things up a little there. Okay. So right now it's just using the same amount of rotation to every cell. And to vary that, we're going to use the second input, the rotation field input. Now to get access to the iteration value for that input, we're going to use the iteration field here. And the format option here has a few different modes. So what this iteration field can do is it can either return the whole thing as a vector, so all 4 parts, or you can pick an individual part. And just for sake of clarity and also to avoid a couple of bugs and some operators that you would need to use if you're just doing vectors, I'm going to use the individual part option, and then I'm going to have 2 of them. So you're going to have one set to x and one set to y. Now what we want to be providing to this rotate is a vector where it's going to use the first 3 parts for rotating along the x, the y, and the z axes. So when you have a field that's producing a single value and you want to get to a vector, the best place to do that is with a float to vector operator. So if we connect these 2 inputs here, and remember that the values, similar thing to what we had before, because the numbers coming out of this are pretty small and it's doing rotation, you need to scale those up. And to do that, I'm going to use a Rescale Field, insert that between the float vector and the rotate. So it's got this output range, and it's got 4 different parts, so you can scale each part separately. So right now, you can scale around the x-axis or the y-axis or z-axis. And just to keep things clear, I'm going to switch this to just 90 for 2 of the axes. I'm going to do the y-axis and the z-axis. And the reason we're doing that will become apparent in a bit. It still seems like we are, even though you've got this other field that's using the second part of the iteration value, it still looks like it's only really making use of the first one. And that's because in float to vector, there are these parameters that let you pick which input you want each part to come from. So in this case, because we want to be rotating on X for one of them. So for this first part, the X part, we're going to go with input 1. It's already what we want. For Y, we don't actually want it to have anything, so we're going to switch that to 0. And for Z, we want to have it use the second input instead. And I'm going to set the 4th one just to 0 for cleanliness sake. It doesn't really matter. So you can already see that it is applying like rotation along one axis based on the iteration from one part of the grid and the other from the other part. So if you switch this down to something smaller, or even just play around with it like that, you can see that this first one is being applied using the kind of x coordinate along the grid, and this other one is coming out of the y coordinate on the grid. And I'm going to go back to just 90 on both of those. Now this on its own is fine, but I'd like to add some animation to it. And what I'd like to do is have it alternately flip on one axis and then on the other axis, and then go back and forth like that. Since what we want to have happen is kind of a series of changes over time, it's at the same interval. Good way to do that is, at least for simple things, is with an LFO, and we can use the pulse option. So it's gonna do a little blip every so often, and you can control how often it does that, changing the frequency. I'm just going to keep it at the default for now, and we're going to connect this to a count. So it's now just a continually counting number, and going to connect that. And you can see how much time I've been spending with RayTK operators when my default instinct for creating anything is to use the RayTK palette, even for jobs, which doesn't work. Going to connect that to a fan, and in here we're going to change this to R and then X and Z. So it's the 2 axes that we want to be changing, and because the range is it's already a large number, it's outside that range, we're going to change the setting here to loop index, so it's going to kind of go back and forth between the two. And I'm going to change the frequency of this down to, I don't know, 0.25. So we've now got a kind of pulse alternating change happening on both of those channels. I'm going to connect that to a count here. So you've now got a separate increasing count for each one, and they're going to kind of increase in alternating pattern. And so what we're going to use this for is to change the scaling angle here on these on the rescale field here for those two axes. And I'd like to have it go in 90-degree increments so that you kind of get this it's always at a right angle in some direction or another. So I'm going to create a math chop, and then in the multiply setting, I'm just going to set that to 90 and add a null on the end here. I'm going to name this, rotation vowels. And then take these two channels and drag that in here, and then to this other one here. So now it's changing in an alternating pattern, but it's kind of doing it suddenly. So to smooth that out, going to use lag. There's a couple of different operators that you could use for this. Filter is another one, but I'm going to use lag here because of the overshoot option that it has. You can now see that it is smoothing that out every time it increases. But this is showing kind of a problem in the way that things are set up right now, which is if you look down further, things go spin a whole lot more down there than they are up here. And the reason for that is because the iteration value that's coming in is, steadily increasing along that axis. Instead, we're going to, on the Modulo 2D, change the iteration type to alternating cell coordinates. So this is, instead of just increasing and going forever in each axis, it's just going to alternate between 0 and 1 on each axis. So you can now see that it is applying the same amount of rotation to each, parallel row and column. And I'm going to set the camera back to somewhere in the middle there. And as part of this lag, there's this overshoot setting, which will, instead of just smoothing out from one value to the next, it will kind of go a little bit further and then swing back a little. So I'm going to set this to 0.1 and increase that a little bit more. So you can see that it kind of overshoots and then bounces back a little bit. And I'm just going to increase the frequency on this just to say 0.5, even put it at 1. And I'm going to decrease that overshoot down so it's just get a little bit of a bounce in the end, but kind of more subtle. And I'm going to increase the frequency up to something pretty fast, go 4. And before we finish up, I'm going to refine this a little bit. Now that we've got the shapes and the pattern that we're looking for, I'm going to go back to 500 by 1000 just for demo purposes. I'm going to add in a point light so we get some more control over the light and aren't just using that default setting. Connect that up to the light input here, and I'm going to set this to an orange 0.7. And so a little bit of a desaturated orange there, and then bump up the intensity on that. And right now it's positioned at the center of the origin, 0, 0, 0. So because that's kind of in line with all of these, it's getting a lot of shadow and stuff. So moving it kind of out in the z-axis and a little bit off to the side there, and play around with that. So that gets us a little bit more interesting coloration, kind of desaturate that a little bit more. And then instead of using the default material, we're going to create our own basic material. Stick this in between here. And you may remember from previous tutorial, but basic material, just for purposes of sanity, I'm going to slow this down. You may remember from previous tutorial that this basic material, uses the regular lighting, and then it has this kind of secondary sort of fake lighting that it applies. It doesn't have shadows or anything, but it just gives it a little bit of an edge. And if we zoom in a little bit there, change our FOV angle so it's looking in a little. You can change which direction that light is coming, or that kind of pseudo light is coming from, and use that to get a little bit more of an interesting shading on the shape. And similarly to with the point light, if it's directly in line in the same plane as all the shapes, then it's just going to be kind of coming at the sides. But in this case, it's actually kind of useful since that gets you kind of like a little bit of a glow around the edges there. And you can also adjust how much the light affects them. So to recap, our scene is based around this link SDF, which is going through a rotate, is going into a modulo 2D, which is tiling space, and then we are setting material on that just to adjust the coloring a bit, and also adding a light and a camera on the renderer there. This modulo 2D is using the alternating cell coordinates iteration type to provide those two iteration values to everything upstream of it. And the rotate is using its second rotate field input to decide how much rotation to apply in each location. That's using these two iteration fields, which are this first one is grabbing the X, the first component of the iteration value, and the second one is grabbing the Y, or second component. And we're using a float to vector to combine those two individual values into a vector, assigning setting the X part from the first input, keeping the Y one at 0, and then setting the Z from the second input. Then using Rescale Field to scale those values up to degrees of rotation. And controlling those, we've got an LFO, which is pulsing every so often, which is then being counted, this ever-increasing count. And then this fan operator is creating kind of two channels, an RX and an RZ, which are the two that we want to be controlling. And it's using loop index so that as this number counts up, it will kind of toggle between the two. That's then using another count, which is providing a separate increasing count for each of those two channels. We're using the math to scale that up to 90-degree increments, and then lag to smooth out those transitions when it changes. Then using those two channels to control the output range for the x and the z parts of the vectors coming out of that. And that is our scene.